Okay, in this video we're going to be finding a vector normal to a surface as well as finding a tangent plane to a surface. And this is also the final part of the first assignment of the Calc D assignments that my class does. So let's take a look. So this is number 41. It says find a vector normal to x squared plus y squared minus z squared equals 6 at the point 3, 1, 2. So one of the things that we definitely need to remember is that a vector normal to a surface is the gradient. So we just need to find the gradient of this thing and then evaluate it at 3, 1, 2. That'll give us a vector normal to the surface. So the gradient of this thing, so I'm going to call it f so that I can just use notation here. Gradient of f is going to be partial x, which is 2x, partial y is 2y, and then partial z is negative 2z. And for this problem, we actually just need to evaluate this. All we're looking for is the gradient at the point 3, 1, 2, because that is normal to the surface. It's also normal to, it's the normal for the tangent plane. So if we plug in 3 for x, 1 for y, 2 for z, we will get 6, 2, negative 4. That's actually the entire problem. So I think the hard part of this problem is really remembering that a vector normal to a surface is the gradient. So let's look at the next one, which just has like a little extra part to it. The extra part is that we don't just want a vector normal to the surface, we want the equation of the tangent plane. That doesn't change the fact that the vector normal to the surface, which is also normal to the tangent plane, or it is the normal of the tangent plane, I guess, is going to be the gradient. So I'm going to look at this thing and I'm going to say this whole thing I'm going to call f so that I can find the gradient of f. I'm going to evaluate that at 2, 1, 1. And then after I do that, I'm going to write the equation of the tangent plane. So let's do that. So the gradient, we need partial x, which is going to be, for the first thing, xz, we're going to get z. For the second thing, we're going to get 4xy. And then the third part, y squared z cubed, has no x's in it, so it's just going to go away when we take the derivative with respect to x. Because the derivative of that with respect to x is 0, because it's a constant as far as x is concerned. So we get z plus 4xy. Now, partial y, the derivative of the first thing, xz, is going to be 0. The second is going to be 4xy. And then the third part is going to be 2y z cubed. So we are going to get 2x squared plus 2yz cubed. And then when we find partial z, the first part, xz, is going to give us an x. The second part has no z's, so it's going to give us 0. And then the third part has a z cubed, so we'll get 3z squared, and then y squared is still there. So overall, we will get x plus 3y squared z squared. Okay, that is the gradient. Now we need to evaluate it at our given point, which is 2, 1, 1. So we're looking for the gradient of 2, 1, 1, which we just plug in, right? So if you plug in x is 2, y is 1, z is 1, we're going to get 8 plus 1, 9. Then we're going to get 2 times 2 squared is 8 plus 2 times 1, so 10. And then we're going to get 2 plus 3, which is 5. Okay, so that's our gradient at the point 2, 1, 1. That is normal to the surface and also, therefore, is the normal for the tangent plane. So our tangent plane is going to just be the dot product of the normal vector and the sort of generic vector. So for our generic vector, we're going to make a vector between x, y, z and 2, 1, 1. So that's going to look like x minus 2, y minus 1, z minus 1. We're going to dot product those and set it equal to 0. Because that's how I always try to write my planes. I always start off with the dot product and then I'll expand them into kind of like point normal form, which I think is maybe a little more common. So I'm just going to do the dot product. And if I do the dot product, whoa, dropped my iPad. Sorry if that blew your ears out. You get 9, x minus 2 plus 10, y minus 1 plus 5, z minus 1 equals 0. You could expand that if you want to, but I'm just going to leave it the way it is. So that's the end of this assignment, the end of this video. I hope this was helpful, and good luck.